Hey, welcome back to Gold Scratch and Happy New Year, the beginning of 2024. 2023 was a great year for us, and we're looking forward to more support. We have lots of plans for unique, interesting videos that hopefully we'll all learn from, and we're going to post a list of those in the future video. So I'm going to share this one with you. Every engine has a story. In this case, it's a mystery story. This engine probably looks pretty familiar. I've done a few Pontiacs in the past. This is a 400 Pontiac engine out of a 1970 GTO convertible 4-speed air conditioning car. So pretty darn rare piece. And the owner brought it to me, called me a little while ago. He had this engine rebuilt by a reputable shop 3 or 4 years ago. It ran fine on the dyno. It made about 375 horsepower. Actually, he gave me the dyno sheet. That's what it made. And that's a pretty decent number for a pretty stock. And we'll talk about all the modifications that were done for a GTO 400 engine. So, however, once he got it in the car over time, and I'm not sure the chronology of all the events, but following things started to happen. You got severe leakage in the rear main oil seal. The engine was making a lot of detonating or pinging, I guess is the way you describe it, under load especially. When he changed the oil, second or third oil change, he noticed debris or shrapnel, metal filings, whatever the term is, in the oil filter. He had a backfiring condition. He identified it on the left bank. And subsequent to that, he did a compression test, and he had 180 PSI compression on 7 of the cylinders. On number 1 cylinder, he had 160 PSI. So I'll get into what I've done about that so far. And the other one was, he said the valve lifters sounded like a typewriter. And probably, if you're watching this, you might have heard that before. Sometimes they are aftermarket valve lifters. But we'll get into what the possible causes of that are. So Merrick brought me this engine and totally disassembled. And so that was difficult for me, because if I had disassembled it, I'd probably learn more in that process. So we have to kind of figure out and kind of use our process to figure out what was going on. So I'll put a shot in here about that. I've already made a detailed write-up on Word, 3 pages long. And for me, I just mentioned 5 pretty serious issues with the engine. And if I tried to solve those all in my head at one time, I probably would miss something. So my process is to write it down, think about it as a science project, because it is. So what are your findings? What are your observations? What are your conclusions? What are the recommendations? What are the consequences? What is the cost? All that stuff is detailed before we spend any money fixing it, to make sure we get it right. Do it the most economical way. Don't spend money that doesn't have to be spent, and yet at the same time have a good product. So I had to do a bunch of things to cover those off. So we're going to go through each one at a time. So just to make the first one, the oil seal, when I took it apart, it still had a rope style oil seal, which is the original oil seal that was OEM. And it was still on the crankshaft. Once again, the engine was in multiple pieces. So the solution of that's probably fairly straightforward. BOP oil seal, I've used these on every Pontiac that I do. It's a 1-piece seal that replaces the rope seal. And whenever I've used it, it's solved that problem. So hopefully that's probably the easiest thing to deal with. The excessive pinging under load, there's 2 or 3 things that could be going on. One is the distributor was an original Pontiac distributor that had been modified. It was the original points distributor, of course. It had been modified to electronic using an MSD module. And Merrick told me that it had been modified, and he wasn't sure, what the conditions were, whether it was done right or not. So timing can always be a big factor. especially with a 4-speed car, because you don't have a torque converter to take up the slack. You put it in high gear, step on the gas, and if the engine's under load and you haven't got the right conditions, you're going to have some pinging going on. And so that's a possibility. The other thing is, what's the compression ratio? So that's one of the first things that I would have to figure out. And so in order to do that, we need to know a bunch of things. We need to know combustion chamber volume. We need to know the deck height, and that's what we're going to show you in a minute here, how far the piston is down the hole. We need to know the volume of the top of the piston, the relief in the top of the piston, the head gasket thickness, and of course the bore and stroke, and all that stuff to calculate your static compression ratio. Then we need to know the closing point of the crankshaft to calculate your dynamic compression ratio and determine compression pressure. So in order to verify that, I'm just going to show you quickly one of the things we do, first of all. So we get the number one piston. I've taken one piston, taken the rings off it, cleaned it all up, taken all the carbon off of it, and reinstalled it in the engine. And I got that top dead center. Let me just make sure I do have it at top dead center. So that's pretty simple. There's a couple ways to do this if you watch the gauge closely. Not at top dead center, no. Yeah, no. Okay, close enough. Okay, so let's go back to where we were. Top dead center. Okay. Sorry about that. There we go. Okay, so once we're sure we have it at top dead center, there's another way to do that with a degree wheel. You can take a positive stop on either side. For measuring the depth of the piston, one of the things you have to notice is the piston can rock a little bit anyway, but measuring the depth of the piston, plus or minus 1 or 2 thou, it's not that crazy. So this is actually a depth mic, but it's actually a metric, so you got to do the conversion. I figured out how to do that. So we zero the depth mic on the dead block. Try to get as close to the center of the piston as possible. Hold it down, and I'm just going to turn it. You're going to have to trust me here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24. Okay, it's about 24 thousandths of an inch the piston is down the hole. That's an important measurement for 2 reasons. One is to help determine compression ratio, and the other one is to determine the quench. And so if you assume you have a 39 thousandths thick head gasket and 24 thousandths thick or depth of your piston down the hole, so 40, 26, you have over 60 thousandths of an inch of quench, which is not ideal, and that can contribute to detonation as well. So we got to deal with that because I calculated the compression ratio based on a 39 thou head gasket. It's 9.7. I have to recalculate it based on using a thinner head gasket, which I'm tempted to do right now because it'll make the quench better and it'll probably actually reduce the amount of detonation. So that's one of the things that we had to talk about. So let's go down. So severe shrapnel in the engine, or sorry, not severe. Some shrapnel discovered, and what Merrick did was he cut his oil filter apart after every oil change, and after the 3rd oil change, he noticed some shiny specks in the filter. And that's the way I used to do that. There's nothing wrong with that process, except it's pretty messy, but it works. So what I do now, the other thing I used to do is strain the oil change into through a paint filter. A paint filter is very fine and it'll stop it. My process now is install this Moroso screen on top of the oil filter, at least for the break-in process. It just sits there. So it does 2 things. It keeps that shrapnel from getting past and back into the engine, number one, and it saves the evidence for you so you know what's going on. So typically I would pull that out after every oil change, take a look at it. If there's something going on, there isn't, but if there is, then you got work to do. You got to find out what's causing it. So anyway, Merrick did that, and that's probably what caused them to say, let's take this engine out. And I'm going to turn it over and show you what it looks like on the other side, because there's a lot of stuff here that's happening that's not adding up, and I'll show you why. So I'm going to turn it over the other way now so we can see the bottom of it. Oh, pin out. I purposely set the engine deep in the rotation stand without the heads on it, because when the heads are on it, it'll be balanced. So that's kind of the idea. So if you come in here and look closely, this is the crankshaft was not in it when I received it. I put the crankshaft in. The main bearings were in it. The bearings that were in it looked like they were brand new, had never been used, and there's no cam bearings in it. Once again, this is all a mystery. How did that happen? Why did somebody take the cam bearings out? There was no rod bearings on the rods. But here's an interesting point, and somebody may have a comment about this. So typically these are Clevite 77s. So Merrick bought me a brand new set of rod and main bearings. They're 10 thou. The cranksman turned 10 thou prior to the rebuild. Okay. And these are the bearings he brought me. This is the way they should be. The top half has a groove where the oil is fed into the bearing first, and the bottom half is solid or flat, doesn't have a groove. So the reason for that is that when your engine is trying to make power, basically it's trying to do is drive your crankshaft right through the oil pan. And so you need as much bearing area as you can have to support the crankshaft. So, however, the bearings that are in it right now, I went ahead and assembled it, and I did the measurements with those bearings. Both halves are like this. Now, I'm not sure. I didn't look before I did. I will when I take it back apart, whether they're Clevite 77s, but why the bottom half of the bearing has a groove, whether that's just an economy bearing or something. I really don't know the answer to that. But anyway, Merrick brought me good Clevite 77s, so they will be going in. But here's the other thing. I'll show you a couple things different about Pontiacs. The registry in a Pontiac is different. So what was DeLorean thinking? You know, he gets the credit for a lot of this. I don't think he really designed it. But anyways, Pontiacs use a dowel. They're all these engines are always 2-bolt main unless they're aftermarket modified to locate it. And that works fine. Whereas a small block Chevy or even a big block Chevy uses a registry. So the main bearing cap fits down into a slot. But one of the things that's interesting is if this engine had debris in the filter did its job, because look at that crankshaft. If that debris was floating through the crankshaft, it would be all scratched up. Now, whether the bearings that are in it when I got it, were the ones that were in it when it was running, I don't think they were. But anyway, the crankshaft looks pretty darn nice. So either the shrapnel got stopped in the filter. A lot of times that stuff gets past the oil filter. People think, by the way, it was balanced. There's the indication that it was balanced. At least it was somebody who added some weight there. So in this case, it doesn't look like it did, because I have checked with the micrometer. Every one of these journals is perfect. It's 10 thou under, the mains and rods. The main bearing clearance is between 2.5 and 3 thou, and the rod bearings. Using the new bearings that were supplied, I've only checked a couple of them. I'm pretty sure that because the crankshaft was fine, 2.5 thou. So all those numbers are good. I have checked piston to cylinder wall clearance, and I'm going to show that because someone asked me on a previous video if I can show how you use a dial bore gauge. So we might as well get around to doing that. So I just got number 5 piston here. I'm going to have to turn the engine back around, Alex, so we can do that. Big deal. Okay. So the nice thing about a dial bore gauge is that all you're really measuring is the clearance. Now, the way we used to do this before that was you'd measure the diameter of the crankshaft and you measure the diameter of the bearing and you subtract one from the other and get your number. In this case, using a dial bore gauge, it doesn't really matter what the piston dimension is. It only matters what the clearance is. So let's start with number 5 piston. So we want to find out what it is. So we measure it with the micrometer. These are Icon pistons. We'll talk about that while we're at it. I was using the other one for example. Icon 891s. These are a very nice piston. They're a forged piston, 1/16 ring package. The R40 thou over. Once again, 14 cc. The dome volume is 14 cc's. Negative volume, I guess you might say. And they are forged pistons. And look at the connecting rods. As far as I know, Pontiac was the only one, maybe Oldsmobile did too, Chevrolet never did anyway, to use a cast. There was a special cast alloy. I forget there's a trade name for it that they use, but they were cast. And these rods, supposedly, according to the builder, were reconditioned. And these are ARP rod bolts. They're really nice ones. They got the little dimple at both ends, so you can use a stretch gauge if you're torquing your connecting rods by measuring the stretch. It's usually about 6/1000 of an inch. The little dimple allows you to locate your stretch gauge in there. So pretty nice piece anyway. And they all look to be in great condition. All the gaps were good. So the other thing that Icon tells you, normally we measure the piston diameter 90 degrees to the pin. In this case, it says to measure it right near the bottom of the skirt. And so I'm going to do that. And I've had this set up pretty close before we made the video. So I don't have to even look at that. I can. And actually I did. I recorded it, but I don't need to know that. Here's what I need to know. So we take the piston out. You know, the micrometer's got the right dimension. Put it in there, it's nice. And you're going to have to come around again, Alex. Sorry about that. I just can only work from this side here. So we zero our dial bore gauge. Okay, if you watch there, it's pretty close to 0 right there. Okay. Then number 5 cylinder. Could have measured it anyway. These cylinders are just about perfect and they're in good condition. So you got to come around this side to see the gauge, Alex. I'm sorry about that. So we try to put the gauge in there, and so if they had 0 clearance, it would line up with this 0. So it's about 5.5 thou. You see how that goes there? Okay. And you can measure it almost anywhere in this bore. It would be almost exactly the same, about 5.5 thou. So the standard or the correct clearance, because they're a forged piston. Now, if it was a aluminum cast piston, hyper-eutectic piston, it would be less, usually around 2/1000 or so. But for a forged piston, according to Icon, 5 to 6 thou is perfect. So that's how you do that. And whether you're measuring connecting rod clearance, bearing clearance, main bearing clearance, piston clearance, basically exactly the same process. Whoever asked for that, hopefully that's helpful. Let me know if you have any questions. Before I forget, Alex is reminding me, like and subscribe, please. I always forget to do that, and you know I always want you to like and subscribe. That's how we keep going. We're planning to make a lot more videos, good quality, interesting videos, but the reason we make them is for subscribers, so we have to keep getting more. Thank you very much for doing that. So we got the piston, the cylinder wall clearance. So I got jumped around a little bit when I said we had to figure out this compression ratio. One of the things we need to know is combustion chamber volume. So here's my setup with my burette. And it's actually leaked down a bit. The answer I got when I did it was about 66 cc's, and I actually did this 2 days ago, and it's leaked down since then. But when I did it, I got 60 cc's. So basically, you seal the cylinder, clean all the carbon out of it. These heavy sockets are just to hold the plexiglass down. This standard one doesn't work very well. I got my own plexiglass that I drilled multiple holes in to let the air out. And the number I got when I measured it was 66 cc. So these are number 12 Pontiac heads, and because it's a 4-speed car, you get the number 12 heads, and they should be 72 cc. So somebody has milled these heads, cut them, or whatever you want to say, which reduces the combustion chamber volume and increases compression. So make sure when you do that, if you're going to do that, you got to make sure that, of course, that the cylinder head is square, level in both directions, and that way you get an even filling of the chamber. So I've taken all those things, the combustion chamber volume, you just saw the deck height, cylinder, the volume of the piston, all that stuff. It's 9.7 with a 39 thou head gasket. I think about that. We might even put a thinner head gasket to improve the quench. I don't like more than 60 thou. So one of the other things always look at, the valve lifters were noisy. So one of the issues is, let's look at the camshaft. So here's the camshaft that came out. It's a comp 268H, and I think the lift is 470, and I'll have to look up the camp card. I think it's around 220, 230 intake and exhaust. The camshaft's in great shape. It looks to me like the wear pattern is equal all the way around. I have mic'd from the toe to the heel on every lobe, and it's got about 2,007-inch difference. It's very awkward to measure that, but it's tedious, but I did try to do that. So there's one final check, is when the cam's in the engine. There's no cam bearings in it right now, so I got to figure that one out. When the cam's in the engine, I will put a dial indicator. I'll put a valve lifter on it and a push rod and put a dial indicator. I'll measure the lift on every single journal, every single lobe, and make sure it's got 470. So I'll divide it by 1.7, whatever that 300 thousandths or whatever on the lobe, whatever that is, and that'll verify the cam's okay. So what the heck happened to the lifters? The lifters originally were the Naughty lifters. I'm just looking at the box to make sure I get. No, sorry, Howard's. So they're in Howard's box. So I'm not sure whether that means that they were Howard's lifters. So they were noisy, and according to Merrick. And one of the things to look at, one of the possibilities is, and I don't know that, I'm going to have to mock up the cylinder head, is the studs that were on Pontiac's stock OEM. I think there's a name for them, bottle top or something. If you can see, they have two different dimensions. And so the way, different than a small block Chevrolet or a big block Chevrolet, where you adjust the preload, you just tighten the nut against the stud, and that gives you your rocker arm preload. However, when you use a different camshaft, different head gaskets, different, you cut your cylinder heads, that geometry might not work out. And for that reason, we may have to go to adjustable rocker arms. And that just means you can buy aftermarket studs that don't have this on them, that allow us to adjust them the same way we adjust the small block Chev or big block or many other engines. Whereas there's some engines like the new LS engines for example, you just tighten them down and all that's figured out for you. So that may be the reason. I don't know that. So Merrick brought me another set of lifters. These are the nice new GM Delphi style with this line on is always an indicator they're probably good lifters. I think they're Delphi Stellite bottoms. And these are actually NOS lifters. The problem with them is they are actually made for an Oldsmobile. So if you look closely, where the push rod goes in, it's deeper than where the push rod goes in for a standard lifter. So that's a problem. The lifters that come out, we don't know that they're in the right order. So that's another problem. So we're probably going to have to change lifters anyways. So the process is going to be, I'll put a cylinder head on, put the rocker arms on, measure the valve geometry, rocker arm geometry, and see whether we can use these lifters. If we can't, we've got to buy different length, custom length push rods. The problem with that is the push rods usually cost more than the lifters do. So it might be better just to go buy a set of Pontiac lifters. So I don't know what the solution, once again, this is a work in process. I don't know what the solution to all that is yet. So let's see if we've covered everything off. So the valve lifter is noisy. the backfiring. Okay, so what I did so far with every cylinder, I poured brake clean into the ports. It's a pretty sort of crass way of checking valve seal. That doesn't necessarily mean they're perfect, but on number one cylinder, the brake clean just poured right out of it. So I know there's a problem there. I haven't taken that apart yet. Because Merrick said it had 180 psi of compression on all the cylinders except that one, that tells me that the rest of these valves are probably sealing pretty good, or it wouldn't have that much compression. On assembly, I'll also do a leak down, and that'll tell us if we've got more problems. If we do, we may have to take the heads back off and do more of them. If not, we can get away with fixing that number one cylinder, and we're good to go. So once again, we haven't solved all that stuff. That's kind of where I'm at moment in time. We need to mock it up and figure all that out before we go ahead. So that's kind of where we're at with this one. We'll make more videos as we go. One of the issues is left is if there is contamination. This block's still dirty. It was sitting around a machine shop for a couple of years. So I don't know whether it's dirty because of that or because we found a little bit of shrapnel inside the block. Really not a lot, to be honest. Crankshaft looks great. So is it justified that we take all the plugs out of it, hot tank it, purge it, jet wash it, to make sure we get that out of there? Or is there a problem? If once again, if the crank's not scratched up, maybe there isn't. One of the problems that whoever built this set me up for, it's a nice modification that's often done. So the original block comes with a pressed-in plug. This is the end of the oil galleys that feed the valve lifters, both sides, of course. So what they did was they drilled and tapped and put a pipe plug in it with a hex, Allen head type hex insert in it. And because it has to be flush, because the timing gear goes there, they milled it off flat. So now, I don't have a tool here, but the hex is so shallow, I haven't pushed the issue yet, but I'm almost positive when I do, it's going to strip the hex, and we're going to have to get that out, probably with an easy out, and that's not going to be fun. So taking all the plugs out of a Pontiac isn't fun anyway, but I'm not sure that I haven't decided that yet, to be honest. We need to get more information. So fairly long video, lots going on. This just shows you how easy you can kind of get in trouble with these engines. Even though it made good power on the dyno, stuff showed up later. And the question is, do we just clean it up? I said that I will probably reuse the rings. Merrick brought me new bearings anyway, so I'll put them in. I'll redo all the clearance numbers again, the same way I showed you. But it looks like we can pretty much use all these parts over again. It's a matter of cleaning and reassembly. So, and check, of course. So, hope you found that interesting. Stick with us. Like and subscribe. Tip of the day. Okay, thanks, Alex. I don't know what I'd do if I didn't have Alex here. I forget stuff. So, tip of the day, I kind of let it out at the beginning, is document, think it through, put it on paper. As I said, I mentioned 5 or 6 pretty major problems with this engine. If somebody brought it to me and I had to solve all those problems on the minute without doing all this stuff, I wouldn't be able to do it. And if I tried to do it without the way I do it, which is write it down in a logical way, think of it as a science project. You know, what you discovered, what you found, what your observations are, what your conclusions are, recommendations are. And each of these things that I mentioned, follow them through logically one at a time and make sure you don't miss anything. Because if you got 5 out of 6 fixed, or 4 out of 5, whatever, and then when you went back together, it would still have pretty major problems. So documenting stuff, you don't have to have a computer. You can do it with a pencil and paper. In my case, this is just a Word document. And all the dimensions I took, if you watched my videos before, you've seen that, will go on an Excel spreadsheet, and Merrick will get that Excel spreadsheet with the package when this engine is running. So hope you found that helpful. One more time, please like and subscribe. Thank you for watching Gold Scratch.